Alright, try this video again. This is about the fifth time I've tried to shoot this one. This is on testing resistance in circuits or circuit components with a digital voltometer. So what we have here is a digital voltometer, and it's pretty much the standard. If your meter is different, it's only going to be slightly different. All of the basic parts are going to be roughly the same. I'm going to start down here at the bottom of the meter and take a look at the ports down here, because these ports are where we're going to plug in our test leads. I'm going to start by putting the black lead into the common port and the red lead into the port on the far right, which indicates that that's where we want to put our leads when we're checking resistance. And you can tell that because right here is the symbol for ohms, and ohms is the value of resistance in electrical circuit. Looks like an upside down horseshoe. It's the Greek letter omega. So I'm plugged in. Next thing I'm going to do is I'm going to set my meter scale so that I turn it on and put it in the correct position for testing resistance. Again, there's my ohms symbol, and I turn the meter on. Now finally, I'm going to take a look up here at the there we go. Take a look at the actual reading of the meter. Right now you'll see that it says OL, and over here on the side you can see a capital M and again the ohms symbol. The capital M stands for mega, which means millions. So I have at least millions of ohms of resistance in this circuit right now, which stands to reason because the OL stands for open line or open loop, which means that I don't have a circuit. In other words, I don't have a current path, so I'm not testing anything. Now, if I take my 2 meter leads and I put them together like this, now I have a current path, and the current path is through the meter leads and into the meter. Okay, and you can see that I'm showing about 1/10 of an ohm of resistance here through the meter leads. It looks like it wants to fluctuate up around 1 to 2. Okay, that's through the meter leads and the meter. Now that is the effect of the leads during my test, so I can subtract that amount from my readings as I go through and actually test parts. Open line, circuit continuity. Start by checking a wire. And here's a wire, and I'm just going to plug my meter lead ends to the ends of the wire. There's 1 and 2, and we're going to take a look now at the reading that we have, and it looks like it's about 2/10 of an ohm. So that 2/10 of an ohm reading is really, since that was what we were showing in our meter leads, going to be roughly 0 ohms of resistance in that wire. It's very low resistance. What we're doing is we're subtracting the 2/10 we're reading now from the 2/10 we were reading earlier. So here's the thing to keep in mind about wires. The longer the wire, the higher the resistance. The smaller the diameter, the higher the resistance. So a long, skinny wire is going to have a higher resistance value than a short, fat wire. Let's take a look at just a resistor. This is a resistor, and I'm just going to plug in, and we're going to take a look at the reading on this resistor. Now, you'll see that I have 0.995 ohms showing. Next to that, it actually says K and then ohms. The K stands for killi, which means thousands. That means that this reading, 0.995, is going to be multiplied by 1,000 to give me the actual ohms value of this resistor. That means this is a 995 ohm resistor. Also notice that if I turn the resistor around, it has roughly the same reading, 0.994 versus 0.995. That's pretty much the same reading all the way through. Okay, and you'll see that we get the 95 floating in there as well. Okay. So what that tells us is that our resistors don't necessarily have a direction that they need to be tested in. Alright, now let's take a look at this. This is a switch. If I plug my meter leads into the switch terminals, I can test the switch. Right now I'm showing open line, so that tells me that there's a high amount of resistance in this switch. Matter of fact, it's an infinite amount of resistance, and that's what I would expect if this switch is off. When the switch is off, there is no way for current to flow through the switch from this terminal to this terminal. When I turn the switch on, however, now I make a path between this terminal and this terminal. Current could flow through there, so my resistance is now very low. So when the switch is off, the circuit's open and I have high resistance. When the switch is on, the circuit's closed and I have lower resistance. Off, no current path. On, I have a current path. So that's how I'd use a DVOM to test a switch. Finally, let's take a look at a light bulb. Here's a standard 194 bulb, and I'm just going to plug into the light bulb connections, and we're going to take a look and see what we got. Looks like we got about 4.6 ohms of resistance in that light bulb as it sits right now. Now, if I take this light bulb and I put the light bulb into a circuit like this, keep in mind we got about 4.6 ohms of resistance. I can also check my light bulb resistance by going to the terminals that connect the light bulb to the circuit. So there I'm connected to those terminals. I come over here, take a look at my reading, still about 4.6 ohms. So that tells me that I have very little circuit resistance from here to here. And the light bulb itself is not changing its resistance. Now here's something to keep in mind. Never plug your DVOM into a circuit when there's current flowing through the circuit when you're on the resistance scale. When you're on this scale, do not plug into a live circuit. You will damage the meter. Alright, now let's disconnect here. Remember that 4.6 ohms. Now we're going to go ahead and turn the circuit on, and we're going to let that light sit there and operate for a minute or two. Once it's operated for a little bit of time, we're going to recheck that circuit and see what the resistance is from here to here. Alright, that should be good. Going to plug in. Circuit is off. Note I turned it off before I checked. Now if I look over here, you're going to see that my resistance has increased quite a bit, and that it's dropping as the light bulb is cooling. So what that tells us is that when we have a resistor in a circuit, like that light bulb, as it heats up, the resistance within that light bulb increases. As it cools down, the resistance decreases. You want to keep that in mind when you're testing, and that's particularly true when you're testing something like maybe a fuel pump. Fuel pumps are one of those things that tend to fail when they're hot and they operate when they're cold. And that's because the resistance of the fuel pump goes up as it gets hot, which reduces the ability of current to flow through the pump motor, and then as it cools off, the resistance goes down, the pump motor can operate normally. So, that's it. That's how to test circuit components with the DVOM.